This video is going to have a look at factorising. Now there's many different kinds of ways we looked at factorising in Year 10, and we're going to be using all of those in our advanced course. So we looked at factorising two terms, okay, with a difference of two squares. So if we had something that was something squared minus something else, we could write that in this format, which we looked at above, but we went the other way. We looked at it this way up above. Okay, so that's just the reverse of the difference of two squares. We actually don't need to have a look at this one at the moment. That's now been removed from the advanced course, so we don't need to look at the sum and difference of cubes. We can have a look at some quadratic or harder factorising, and we'll have a look at those below. We'll have a look at some perfect squares and grouping into pairs. So let's see what we can do down below here. So let's factorise the first one. 3x plus 12. We're looking for a common factor in both of those, and what's common to 3x and 12 is 3. So we pull the 3 out the front of the brackets, and we're going to think, well, what do I times 3 by to get me 3x? So 3 times x will give me 3x. What do I times 3 by to give me 12? It's going to be 4. 3 times 4 is 12. So that one is nice and straightforward. Okay, looking at number 2, y squared minus 2y. What is common to y squared and 2y? It is y. What do I times by y to get y squared? Well, it needs to be y. What do I times y by to get me minus 2y? It needs to be minus 2. So you're just checking back. Y times y gives me y squared. Yep, that fits right. Y times minus 2 gives me minus 2y. So that one's right as well. Looking at the next one here. What is common to x cubed and 2x squared? Well, x is common, but we want the biggest thing that's common. So the biggest factor of x cubed and 2x squared is x squared. So we want that biggest number, otherwise we're going to have to factorise it again. Okay, x squared times x will give me x cubed. X squared times what gives me minus 2x squared? It's going to be minus 2. And you're always checking x squared times x, x cubed. Yep, that's right. X squared times minus 2 squared. That's right. Okay, question 4. This one's a little bit harder. So 5 times x plus 3 plus 2y times x plus 3. Now this is the reason why I don't like you to FOIL in your expansions, because it's basically an expansion but going backwards. So the thing that's common is x plus 3. And what we do when we factorise our x plus 3, well, we think, well, what do I times x plus 3 by to get me 5 times x plus 3? It's going to be 5. What do I times x plus 3 by to get me 2y times x plus 3? It's 2y. So if you think about what we did above, we've basically split this bracket up in here, and we've reversed our expansion. So that's why I like to not use the FOIL method. And looking at question 5, what's common to this first term here and this second term here? Well, there's going to be a number that's common. So common factor of 2 and 8 is going to be 2. But we've also got letters that are common. So common factors of a cubed and a, well, the biggest letter that goes into a cubed and a is going to be a. The highest common factor of b squared and b cubed is going to be b squared. Now we're checking, just by opening our brackets, I'll just pop the arrows on the bottom here. What do I times 2ab squared by? What goes in here so that when I times it, I get 8a cubed b squared. Well, it's going to be 4a squared. Now we're looking at the second part. What is the second thing in here that I need to have so that when I multiply it by 2ab squared, I get minus 2ab cubed? Well, it's going to be minus b. And you can check your expansions and check that you're right. If you multiply them out, do I get what I had? Yes, I do. Okay. Question 6. We've got x squared minus 2x plus 3x minus 6. Now there's actually a couple of ways to do this one. And the first way we're going to do is by basically splitting up our sets of numbers and looking at common factors in the two sets. So I can, and I'm looking for a common thing between the two of them. So if I was to pull out an x out of these first two terms, I'd end up with x minus 2 in there as well. So if I expanded that out, I'd get x squared minus 2x. So they're my first two terms. If I have a look at the second two terms, what's common to those two is 3. So if I factored out a 3, what I'd have in my brackets, okay, if I factorised it, would be x minus 2. So what I've found is that I've got an x minus 2 that's common to both of those. So what I then could do is I could factor the common thing out of both of these terms, which is x minus 2. And what do I have left? I've got an x plus 3. Okay. So that's one way to do those ones. Later on, we'll have a look at the other way, which is adding like terms in there, which I'll get as x squared plus x minus 6. And we'll look at that in another video. But what we looked at last year was saying, well, how do I factorise that? I'm looking for two numbers that will add to 1 and multiply to minus 6, and that'd be 3 and minus 2. So you might remember how to do that. If not, we will look at that in another video. Okay, looking at 7. 7 we can't do that way we did up above because there's no like things that we can add together. So we're looking at factorising in pairs, and then hoping when we factorise in pairs, we'll end up with things in the brackets that are the same. So if we have a look at our first two here, 2x and minus 4, so there's a little squiggly line. I might fix a little squiggly line up in the middle. So we're looking at the stuff on the left and the stuff on the right. Factorising a 2 out of these two terms, I end up with 2 brackets x minus 2. Looking at our second two terms, I can factorise out a minus 3y. That's the highest common factor of those. And I end up with a, depending on which way you do it, I'm going to write it as x. We'll write it that way first, 2 minus x. Oops. I'm going to rub that out and do it how I think you guys would probably do it. I'm thinking how you would do it. You would factorise out a 3y and have a plus in there. And then you would go, okay, we would end up with a 2 at the front there, and then we'd end up with a minus x in there like that. And in doing that, what you would find you would end up with is x minus 2 in our first bracket and 2 minus x in our second bracket, and they are not the same. But what I could do is pull out a negative out of this bracket and make this positive a negative, in which case I would end up with a minus 2 and a plus x. And I could rewrite that minus 2 and plus x as x minus 2, which is the same as the first bracket. Okay, so there's a little trick in there, is understanding that sometimes taking out a negative is going to flip the values or the signs in front of our things in the brackets, and then that's going to be to our advantage. In doing it that way, I can now factorise out x minus 2 is common to those brackets. And what do I have in here? I'm going to have a 2 and a minus 3y. Question 8, d squared minus 36. Well, when I get a question like this with a squared and a negative, I like to see if that second term is something squared, and it is. 36 is 6 squared. So a difference of 2 squares, I can write it as d minus 6, which I've got there, and d plus 6. You can pop the minus in there and the plus in there and have them switched around, but as long as one's a minus and one's a plus, and there's a d and a 6 in each of them, that's a difference of 2 squares. Okay, question 9 here is also a difference of 2 squares, because we can write our first term as 3 squared b squared minus 1 squared. Remembering 1 is 1 squared. It's the same, and probably something a lot of people will forget. There's a negative, and each of these terms in the front are squared. So we can write it as 3b plus 1, 3b minus 1, using our difference of 2 squares formula. Okay, m squared minus 5m plus 6. We're looking for two terms that will add together to give you minus 5. Okay, add and multiply together to give you 6. I like to use the a and the m. And I remember that a comes before m in the alphabet, so adding comes before multiplying when I'm working out factorising a quadratic. So what two numbers would add together to give you minus 5 and multiply together to give you minus 6? Well, it would be minus 2 and minus 3. Minus 2 times minus 3 is 6. Minus 2 plus minus 3 is minus 5. And they go in our brackets, and we pop an m in each bracket. So in number 11, we're looking for two numbers that will add to give us 1 and multiply together to give us minus 2. What are those two numbers going to be? So you're going to have to play around with them, okay? I look at the multiplication options first. I'm going to have minus 2 and 1, or 1 and minus 2. 2 and minus 1, they work, and when I add them together, I do get 1. So I'm going to pop a plus 2 and a minus 1 in there. Next ones. Okay, so we're looking for numbers that are going to add to minus 8 and multiply to 16. Okay, so if you like to write them at the side, you can do that. We're looking for numbers that are going to add to minus 8 and multiply to 16. It's going to be minus 4 and minus 4. Minus 4 and minus 4, multiply to 16, add to minus 8. So we're going to write our minus 4 and minus 4 in each bracket, but we can also write them as, because they are the same, as x minus 4 squared. Okay, now there's a couple of ways to do this one. I'll show you both, but I'm going to use the green method on the right most of the time. So I've got 5y squared minus 13y plus 6. Now this is what we call a non-monic quadratic, because there's a number out the front of the squared term that isn't a 1. So in this case, it's a little bit different. We're looking for terms, and I'll just get rid of those little bits, that are still going to add to minus 13. Okay, but we're looking for terms that are going to multiply to not just the 6, but the 6 times 5. 6 5s are 30. So we're looking for terms that are going to multiply to 30, but add to minus 13. And if I think of what those are going to be, they're going to be minus 10 and minus 3. So the first method, what I would do would be I'd still write my 5y squared, and I think, well, it's minus 10 and minus 3. And I'm going to write them down with a y in them. So they are the minus 13y term split up into the minus 10 and the minus 3. So we end up with, if we added them together, minus 13y, and then I have my plus 6. So that's where this comes from. It's just rewritten again down below. So if I then split my term up, okay, into two sections, I'm looking, like we did before, factorising each section so that I get a common factor that I can then factorise out again. So common to both 5y squared and 10y is 5y. If I factorise 5y out of those first two terms, I end up with y minus 2. What's common to the second two terms? It's minus 3. If I factorise out a minus 3, I get a y minus 2 again. So y minus 2 is common. If we don't get something that's common, we've done something wrong and we need to go back and maybe alter it, pull out a negative, or play around with it. If we factorise out the y minus 2, what am I left with? I'm left with a 5y minus 3. That's one way. Here's my messy writing and another option. It's the same as before. We're still at the same question here. We're still looking at things that are going to add to minus 13 and multiply to 30. And we said, same as before, they're going to be minus 10 and minus 3. Okay, so what we do is we pop a format up that looks like this. Okay, I'm going to pop a 5y in each bracket because 5y is what's out the front, 5y squared. So we're going to go 5y and 5y. But I need to divide by the term that's out the front as well. The reason I need to do that would be that if I was to expand this, my first term would be 5 times too big, and I'd get 25y squared. So that's my format that I would pop it in. So I said my terms that would add to minus 13 and multiply to 30 were minus 10 and 3. So I just get those two and I write them in there, minus 10 and minus 3. Now, we don't like this 5 on the bottom, so we need to divide the 5 away. We need to divide the 5 just into one bracket. 5 won't go into the second bracket because there's a minus 3, but it will divide into the first bracket. So if I divide each of those two terms by the 5, I'd end up with y minus 2 as my first bracket and 5y minus 3, which is the same as what we had over here. So for the second one, I want you to decide which way you prefer to do it. Here's the splitting method. I'm not going to do it that way because I don't like that method. I'm going to use my other method on the right over here. But you don't have to do that method, okay? So here's my question. What I'm going to do, and this one's a little bit different. I'll set it up for us. Okay, so here's our question. 4y squared plus 4y minus 3. We're looking for two terms that will add to 4, okay, and multiply to 4 minus 3. So multiply to minus 12. So those two terms would be 6 and minus 2. So what I've done is set this up like before. Get my 4y and my 4y and that 4 on the bottom. And then I just get my two factors and I write them in. And what I need to do is divide that 4 into one of those brackets. But if you look at this question, it doesn't divide into one bracket evenly. So I need to think, how else can I write my 4? I could write my 4 as 2 times 2. Now it needs to be a multiple of two numbers. And then I can divide the 2 into this bracket and the other 2 into this bracket, into each of the terms. And so what I would end up with is my first bracket would become 2y plus 3, okay, because the 2 is divided into each of those terms. And my second bracket would be 2y minus 1. But again, if you didn't like that method, there is the other version to do.